Feel welcome, my good students. Today, just a short area on vectors. Want to do a question on vectors so that we can actually use that question to understand more on how to tackle questions related to vectors. The question goes, is the midpoint of AB? OD to DB is in the ratio 2:3. F is the point of intersection of OE and AD. Further, OA equals to A and OB equals to B. So the question goes, A, express OE and AD in terms of A and B. From the diagram, though not drawn to scale, we can see that OA, to move from O to E, we have to go from OA plus AE, which is the same as OA plus a half AB, which is actually A plus a half. Then from A to B is AO plus OB. Now, substituting in the values of those vectors, we have OE equals to A plus a half into bracket negative A plus B equals to A minus a half A plus a half B. And if you simplify that one, you get that OE equals to a half A plus a half B. Problem 2, you are supposed to get AD, and AD is equals to AO plus OD, which again, we can simplify that one by saying that AD is equals to AO plus 2 over 5 OB. By substituting that one, we get that it is negative A plus 2 over 5 B. Question B goes that given that AF equals to TAD and OF equals to SOE, find the values of T and S. Remember, to find the values of T and S, then you have either to express AF or OF in two different ways, and then the resulting equation, you can solve them simultaneously. Let's proceed. So we are going to express AF in two different ways, which are as follows. AF will be equals to TAD, and if we substitute the values of AD as we got from question A, then we have that AF is equals to negative AT plus 2 over 5 TB. Similarly, AF can also be expressed as AO plus OF, which is the same as AO plus SOE. And if we substitute the values of OE, the vector OE from up there, we have that this one reduces to negative A plus S into bracket half A plus half B, which we refer to this case as equation 2. We can simplify equation 2 so that we end up with A into bracket a half S minus 1 into close the bracket plus a half SB. Remember, I'm putting the like terms in equation 2 to get equation 3. Now, to solve the values of T and S, then you are going to equate equation 1 and 3. And if you so do that, you get equation 5, which is negative AT plus 2 over 5 TB equals to A into bracket a half S minus 1, then plus a half SB. Let's refer to that as equation 5. Then we can proceed on from equation 5. We now equate the components, that is the component of vector A to A, then vector B to B. By so doing that one, we get equation 6, which negative AT equals to A into bracket a half S minus 1. Simplifying that one, we get 1 minus T equals to a half S. Let's call it equation 6. Similarly, from 5, we can again equate components of B, which now goes to 2 over 5 TB equals to a half SB. Then this one can be simplified to reduce into 2 over 5T by cancelling B. 2 over 5T equals to a half S. Now, next, we solve equation 6 and 7 simultaneously to have 1 minus T equals to 2 over 5T, which implies that 1 equals to 7 over 5T. If you simplify and make T the subject, we have T equals to 5 over 7. And at the same time, if we substitute the value of T in equation 7, we have S equals to 4 over 7. Now, the C part of the equation was to show that O, F, and E are collinear. Collinearity simply means that you show the 3 points lies on a straight line. So if you are to show 3 points lies on a straight line, the first step is to form two vectors. Then after forming the two vectors, you need to show that those two vectors are parallel. And how do you do that? You actually show that one of the vector is a multiple of the other. Once that one is met, then you proceed on to show that those two vectors shares a common point. If those two vectors meets the two conditions, then you are at liberty to conclude that the two vectors are collinear. So we have to prove collinearity, then we need to show that the two vectors are parallel by showing that one is a multiple of the other, and number two is to show that they share a common point. Now let's move on. Now we'll form two vectors, that is OF and OE. Then we'll show that OF equals to KOE. That means OF is a multiple of OE by a factor K. So we'll proceed on to find that value of K by substituting in OF, that is vector OF, and also vector OE. By so doing that one and simplifying that, we end up with K being 4 over 7, implying that we can now write OF equals to 4 over 7 OE. Clearly, OF is a multiple of OE by a factor 4 over 7. And therefore, we can conclude that OF is parallel to OE, and since they share a common point O, they are collinear. So I believe that short demonstration is enough for you to master that area of vectors. Follow me and subscribe for more lesson and video to follow. Thank you and be blessed.